Salvete Christiani, frates et sororos num. So, today we're talking about enzymes. So, what are enzymes? We went over enzymes in my last vid. We did a little bit over it. So, enzymes, they speed up a chemical reaction. They're proteins that speed up a chemical reaction because they decrease the activation energy. So, what is activation energy? The activation energy is the energy needed to start a chemical reaction. What enzymes do, they decrease the amount of activation energy, which in turn speed up the chemical reaction. See? So what is energy? And energy is the ability to do work. And there are many forms of energy. There's mechanical, kinetic, um, thermal, nuclear. Now chemical. We're gonna discuss chemical because chemical is the most known most known energy inside of biology. It's chemical energy. So chemical energy comes from the food we eat. Food is chemical energy, basically. And there's always a flow of energy. When we eat food, right? Let's say I eat some broccoli, carrots, green beans, apple, banana, right? Let's say I eat that, probably some eggs and some milk, right? It's a lot of food. Let's say I eat that, right? Then as I talk and as I move, takes the chemical and turns into mechanical energy. So when I go, jog or something, all that food I ate, the chemical energy turns to mechanical because I'm contracting my muscles and stuff to run. So that's just the natural flow of energy. Let's talk about energy and chemical reaction. So I'm about to name a chemical reaction, right? Let's see if you know what it is. 6H2O plus 6CO2 equals C6H12O6 plus 6O2. What does that sound like? Did you guess it? Right. Photosynthesis. That's what the chemical reaction is. 6H2O plus CO2 equals C6H12O6 plus 6O2. When looking at a chemical equation, I don't think I could put one down here because I don't know how to type a chemical equation in. But if you look at one, the left side of the arrow is called the reactants, right? And then on the right side, you will call that the product. Let's discuss more in detail of what activation energy is. So almost all chemical reactions need some type of boost or start or some type of input energy. So that's what activation energy is. An example of activation energy is that if you wanted to burn, like, let's say you want to smoke weed, right? You know what? Let's not use that example. Let's say you want to burn paper or you want to burn some wood for your fire, right? Let's say fireplace. How would you burn the wood? You have to raise the temperature of the wood so that it will create fire, right? You have to, and once the fire is made, you have, thermal energy, then you have light energy, right? So that's how you would start a fire, the activation energy. You have to raise the temperature of the wood to start a fire. You understand? See? Pretty cool, right? Pretty simple. Oh, yes, always. The initial energy input is called the activation energy. The activation energy. That's basically to start off the chemical reaction. So, like, we're going to talk about energy transfer. All right, so there's some chemical reactions out there that are called exergonic. Exergonic is when not energy, well, yeah, energy. It's when energy is released. That's what exergonic means. The example of exergonic would be respiration. I think, yes, respiration is when you see, that's respiration. Now you can remember that exergonic means to release because it has a little X. Exit, like out. Now there's another one called endergonic. Endergonic is when they take energy in. For example, like I just described, photosynthesis. Photosynthesis is the method that, well, not method, but the way that plants get their food. They have that's an endergonic reaction. They take in energy. So you can remember ender, it sounds enter, it takes in, it goes in, right? So let's talk about catalyst. What is a catalyst? Yeah, it's mosquitoes out here. So. But what is a catalyst? Basically, a catalyst is catalyst substance, right? A catalyst is a substance that decreases the amount of activation energy needed to start a chemical reaction. Now, you might be thinking, isn't that enzymes? Yes, enzymes are a group of not chemical, catalysts. Basically, what catalysts do is they make um they make chemical reactions start off easier, things like that, because at the beginning of chemical reaction, normally the activation energy is extremely high, extremely, extremely high. So what catalysts do is they decrease the activation energy. So basically, like I said earlier, all enzymes is a type of group of catalysts. Now, some organisms may have thousands of types of not catalysts, enzymes. And all enzymes do is decrease the activation energy and in turn speed up the chemical reaction. That's what a catalyst is, and enzymes is a type of catalyst. Now, all enzymes end with I would say suffix, right? The suffix ase. So for some examples, lipase, sucrase, maltase, those are just three examples of some enzymes. So let's discuss the lock and key model. So what is a lock and key model? Lock and key model is a model that explains what enzymes look like and how they function. Of course, I mean, I don't think I can show you. It'll be, I don't know if I can insert a picture in here, like, because I don't know how to record my screen. But if I could, yeah, I would show you lock and key model. But basically, enzymes have these little grooves, right, inside of them called active sites. And basically, a substrate or a reactant, whatever you want to call them, it would, plug into the enzyme. It goes inside the active site. Now, all enzymes, they are specific for every substrate. So if you have an enzyme and you have lactose, it has to be lactose. Not all substrates can fit to any enzymes. They have to be very specific. You see? After the chemical reaction has occurred within the enzyme, the enzyme creates products after that. And after the chemical reaction has taken place, the enzymes never do change. Now, during a chemical reaction, enzymes are not used though. Like I said earlier, that they are specific, so you can't just take any substrate and plug it into any enzymes. They have to be specific. One more thing, I want to talk about substrates. So a substrate is a substance that enzymes act upon. So basically, a reactant and a substrate, they're the same. You can call them either one. Substrate, reactant, same thing. Well, that's pretty much it for enzymes and biocatalysts. So, talk to you guys later. Valete.